Earlier today, a destructive earthquake struck offshore of the southeastern Philippines. This quake caused some buildings to partially or fully collapse, resulting in widespread damage in some areas, caused at least 7 fatalities, and even generated a tsunami. The earthquake in question struck at 9:43 a.m. local time on October 10, 2025, specifically at a spot 24.5 kilometers east of Manay Bay, offshore of the island of Mindanao. Registering in as a major magnitude 7.4 quake, this event was lengthy, lasting around 40 seconds. Here is a simulation of the most intense ground shaking the region experienced, and now here is another simulation showing how a reinforced concrete structure, the most common structure type in Mindanao, might fare. However, due to the unusually large area which experienced MM4 or greater ground motion, landslides generated by said ground motion also destroyed at least a dozen structures. Potential liquefaction damage is also modeled to be widespread, but I have been unable to personally verify anything suggesting such a widespread extent of this damage type as modeled by the U.S. Geological Survey. They also modeled the quake's likely casualties and economic damage as shown here. Thankfully, the tsunami which struck was very small, not causing any damage since it reached no higher than 8 inches or 20 centimeters in height. And then, 10.5 hours later, another large quake struck, registering in as a magnitude 6.7, with this large event causing some further damage, albeit of a more limited extent. That latter quake was not an aftershock, but rather a doublet event where 2 large main shock earthquakes occur in close proximity to each other in time and distance. Now, I know what everyone is thinking. Are these 2 quakes a result of Cebu Island's destructive September 30th quake? To this I say absolutely not. Completely different geologic settings were involved, and the 2 sets of events were too far apart for the Cebu Island quake to have triggered today's quakes. These distinct events just so happened to represent coincidental cases of bad luck that were closely spaced in time. On that note, today's earthquakes were both highly unusual, meaning they were scientifically interesting. They did not occur at the plate boundary like most regional large magnitude quakes, but instead both occurred solely within the subducting slab. Such events are known as intraslab earthquakes, and it is very rare for these to occur in the magnitude 7 range. As to the east of the island of Mindanao, a tectonic plate collision is ongoing. Here, the Philippine Sea Plate is subducting underneath the Philippine Mobile Belt. This subducted slab bends as it descends, and due to varying factors, the slab is pulled downwards at a lesser rate the deeper you go. This allows for compressional strain to build up until it is released via a thrust fault on the subducting slab. Such a series of events occurred twice today at depths of 58.1 kilometers for the magnitude 7.4 quake, and then 61.2 kilometers depth for the magnitude 6.7 quake. Both earthquakes also had a partially oblique motion to them, specifically a left lateral one, which reflects the horizontal strain generated by the non-straight-on collision the tectonic plates are undergoing. The primarily thrust fault portion of the larger 7.4 earthquake appears to have even uplifted a section of a particular shoreline by a full 2 meters despite its depth, indicating the sheer energy involved in today's event. While more aftershocks are likely, earthquakes of a larger magnitude in the next week from the immediate vicinity are statistically unlikely. No apparent volcanic activity has been triggered by these 2 offshore quakes, and it seems to me that today's 2 quakes caused, when combined, less severe damage than the recent Cebu Island earthquake. The main reason for this is the vast difference in the epicenter depths of these earthquakes. As a final note, I would like to thank my new YouTube channel member Steve Muller for supporting my work.